Today is October 10th, 2018. My name is Martin Frank, and I am at the University of Mississippi Medical Center to interview a friend and colleague, Dr. John Hall, for the Society's Living History program. Dr. Hall is a long-standing member of the American Physiological Society, and he has been affiliated with the University of Mississippi since 1974 when he came to Jackson to take a postdoctoral position in the laboratory of Arthur C. Gaytan. Dr. Hall is currently the Arthur C. Gaytan Professor of Physiology and Chair of the Department of Physiology at the University of Mississippi, a position that he has held since 1989. Dr. Hall's research has focused on multiple aspects of cardiovascular, renal, and endocrine physiology. And currently, his interests revolve around the area of obesity, insulin resistance, and chronic renal disease. John, welcome to the Society's Living History program, and thank you for allowing us to interview you and helping our membership learn a lot about you and your career.
Well, thank you, Marty. It's a real pleasure to be here, and it's an honor to be part of this Living History series, and it's a special honor to be interviewed by you. So let's go, let's roll.
All right. In preparing for the interview, I learned a bit about you. Mm-hmm. One of the things I had always understood was you were an Ohioan. Yeah. But as I learned about your career, I actually learned that you initially spent the first 6 years of your life in Milo, West Virginia. Mm-hmm. So I would be very interested if you could tell us about those first 6 years of life in Milo, West Virginia, and what Milo was like and what it was like for you as an individual growing up.
Well, one correction, it's 5 years in Milo, but Milo is a place that hardly anybody knows. It's a beautiful area of West Virginia. It's in the middle of nowhere. The town population when I was there was 6.
Which is probably where I got the 6 years.
Yeah, my grandparents, from my dad's mom and dad, my mom and my dad, and my older sister and I were the only residents of Milo, West Virginia. My grandfather had a farm, but he also ran the sawmill and the feed mill. My grandmother ran the post office, which is why it was a city or a town, I guess, because it was a location of a post office. In fact, if you Google it, you can still find it, but there's not much there. And also a general store. My grandmother ran that as well. We had a one-room school that my aunt taught at, and I was fortunate, I think, to go there when I was about 4 years old to grades 1 through 3, but obviously didn't make it to grade 3. But anyway, it was a very small town, beautiful area, and I lived there for the first 5 years. And the good thing about it, I think, was I spent a lot of time with my dad, because my dad he ran the farm, and I spent almost every day with him. So it was really, really a great place to grow up.
When you were 6, your parents and family relocated to Smithville, Ohio. Mm-hmm. Can you tell us about growing up in Smithville and how Smithville was somewhat different from Milo?
Yeah, well, Smithville's just a little bit bigger. It had about 500, 600 people. My dad was called to World War II in 1942, almost a month after my sister was born. And I was born about 10, 11 months after my dad got back from World War II. So as I said, we lived there for 5 years. We moved to Smithville. He wanted to, I guess, strike out on his own. He bought a house with some land, and we had several acres in which we grew a lot of things. We grew all of our own food. We had a couple of horses. We had a cow. I think the thing about Smithville, which is so great, is that it was a small town. Everybody knew everybody. We learned to work hard because we had a lot of land to take care of, cow and horses, and we grew our food and so forth. We had paper routes. We grew up typical, I think, idyllic sort of childhood. My main interest growing up was really sports, athletics, and working. We did learn how to work hard, and I think that's one of the things my parents taught me. Probably the most important thing early on was really the value of hard work, some discipline. I needed a lot of discipline when I was a little kid, I have to say. But we had a really, really good childhood in Smithville. Smithville was a wonderful town. I still have communication with my classmates from school, and it's just a wonderful little town.
Now, Smithville is also where you developed an interest in science. And can you tell us a little bit about that?
Yeah, it would be an exaggeration to say that I developed an interest in science at Smithville. As I said, my main interest was in athletics. Until high school was athletics and girls. Those were my main two interests. And I really had some really good I was always interested in science, but I really didn't think about science as a career. In fact, I started off thinking about journalism and English as a career. And that was due mainly to the fact that I had a really, really good high school English journalism teacher. And on the way home from basketball practice one night, she just kind of pulled the car over and told me to get in the car. And I was a little concerned at first. I didn't know what that was about. But she said, you know, you write pretty well. You know, I'd like you to be the editor of the yearbook. And I'd like to send you to Kent State University for a summer workshop and learn how to be an editor and so forth. So I went to Kent State for a journalism workshop. I became very interested in writing and English. As it turns out later, this was really a good experience. Most of my career has been filled with writing, actually. So as a scientist, probably one of the most important things you can learn early on is how to write effectively. I'm not saying I was a good writer, but at least I was good enough to be...
You were an effective writer.
I was good enough to be the editor of the yearbook. So in high school, I started off with not much interest in really academics at all. I finished with a real strong interest in journalism and English. And that's where I went to college to major in journalism and English.
And presumably that summer workshop at Kent State contributed to your decision to go to Kent State after you graduated from high school in 1964.
Yeah.
And if I remember correctly, that was where you got introduced to Arthur Gaytan.
Well, indirectly.
In a manner of speaking.
Yeah, sort of indirectly. I went to Kent State, as I said, to major in journalism with the idea of ultimately becoming a high school journalism English teacher. About the second year, mid-second year, I had one of my advisors used to sit and talk with me a good bit. She was a big anti-war activist at Kent State. I was pretty conservative. Most of the people around me had hair, you know, to their shoulders. I had a crew cut as a rebellious sort of thing. But she asked me about my interests and so forth, and she said, you know, you're doing really great. You're making essentially all A's, but you know, you just don't seem like an English teacher. She said, have you tried science? Have you tried any advanced courses? You did well in biology. Have you tried any advanced courses? And by luck, I took a physiology course, and I had a tremendous teacher of physiology. Dr. Keith Ewing. And I want to go back to say that my high school English teacher, I really never got a chance to thank her. Her name was Eileen Barrett, and she was a tremendous teacher. But Keith Ewing was also a tremendous teacher. He had a course in biology which was considered the hardest course, and the book that we actually started with was Tuttle and Schoteless. It's an old physiology. It wasn't the Gaytan textbook. But after I did well in the course, he offered me an opportunity to do some research in thyroid physiology. And he then let me read this book, Gaytan, Textbook of Medical Physiology, and I ended up buying a copy of it. So that's how I got introduced to the textbook of physiology. But I started my research with Dr. Ewing really focused on thyroid physiology and endocrinology. We were trying to understand the development of the thyroid gland. And as I said, he was a tremendous mentor. He later became chair of the Department of Biology there. And I corresponded with him the last couple of years. I think he's 85 or 86 now. And we communicate occasionally, not very much, but he's really a really great person.
John, you graduated from Kent State in 1968 at during the Vietnam era. And obviously you had choices to either go to college and get a doctorate or enlist or get drafted. And tell us what you ended up deciding and why and what that experience was like.
I have to correct you again. I didn't have choices. I already had a fellowship. I had applied and got a full fellowship to Michigan State University that had really a tremendous endocrinology program. They had a person there by the name of Joseph Mites. I don't know if you heard of Joseph Mites. Was a pioneer in neuroendocrinology, and Paul Reinecke, who also was a sort of pioneer in thyroid physiology. So I applied. I got a full scholarship. I called the local draft office and I said, I have this scholarship, full scholarship to Michigan State University. I'm going to be exempt, right? And the local draft board, the lady who ran it was actually the mother of my college roommate. So I thought maybe, this would be okay. But you remember, this was the height of the Vietnam War.
Right.
And she said, no, I'm sorry, your 4 years of exemption are completed. Probably 3 weeks later, I got a letter saying, welcome to the United States Army. I've forgotten exactly what the letter said, but I got drafted.
Your neighbors have selected you.
So I got drafted. I went to the Army. I did basic training in Fort Knox, Kentucky. We were told then that all of you are going to Vietnam, and you're going to be artillery, infantry, or engineering. And by the way, what do you think you're good at? So I put laboratory specialist. That didn't fly very well. So I ended up, after finishing basic training at Fort Knox, it was in August. There's a place called Heartbreak Hill in Fort Knox, Kentucky. So we had a rigorous basic science or basic training. Fortunately, I was in pretty good shape at the time. Finished basic training and was chosen to be in the engineer training. So I went to Fort Belvoir, Virginia, where I got trained in engineering and learned. Really turned out to be quite good. I learned a lot about electronics, which turned out to be very valuable later on in my career. So I've had a series of lucky breaks, I think, throughout my career. And then, they told us again, you're all going to Vietnam. And so, I assumed I was going to Vietnam. In my class, I think there were 44 in my class. 42 went to Vietnam. I ended up going to Germany, where I was part of the 32nd Air Defense Command. That was a surface-to-air missile command, and this again was part of this was sort of the time period when we had a Cold War going. So our job was to shoot down the Russian bombers as they attacked Western Europe. I learned a lot there as well. I learned, again, more about electronics. I learned how to build launch sites for missiles. I learned how to drive a bulldozer and so forth and so on. But those 2 years that I spent in the Army, it turned out to be really lucky. I learned a lot, number one. It made me really focus more on what my career goals were. And you and I have talked before, I really think 2 years of national service would be a great thing. Not necessarily the Army,
no,
but national service, because it really helps you focus on what your goals are. I got out of the service 2 years later in August. I headed for Michigan State in September and started graduate school at Michigan State University in September of 1970.
And you work with Jim Schwinghammer, and Fran Hattie was the chair of the department, I believe, at that time. Tell us a little bit about what you did there in terms of the research and how that progressed.
Well, again, I had thought that I was going to be an endocrine physiologist, so I went to Michigan State with that in mind. And actually, one of the faculty members I thought I was going to work with was on sabbatical. So it turned out I was sort of put in Jim Schwinghammer's lab sort of temporarily, and it turned out, again, very lucky break. I was his first graduate student. He had just finished his postdoctoral training with Fran Hattie, who was the chair of the department. Dr. Hattie was a well-known cardiovascular physiologist. I think he was the first recipient of the Wiggers Award, which is sort of the top cardiovascular award, and Dr. Gaytan received that award later. But Dr. Hattie was really a top chairman, and he had a strong cardiovascular group. Jim Schwinghammer turned out to be a tremendous teacher. He won every year teaching awards from the entire school, the College of Natural Sciences, the entire school. So again, a very lucky break that I got paired up with Jim Schwinghammer. I was his first graduate student. Unfortunately and sadly, Jim died a few years after I got my degree. He had leukemia, and so he really only had a chance to train 2 graduate students. but I did get a tremendous education there. Our work related to 3 areas really. One was hemorrhagic shock, endotoxin shock, and hypothermia. And our interest was in understanding how those pathophysiologic conditions affected the control of the microcirculation, the neurohumoral control of the microcirculation, and transcapillary fluid movement. So I had a really good experience there. We did experiments every day. In those days, we did experiments during the day and we studied at night. It's a little different nowadays, but we worked hard all day long. We studied at night. So it was a tremendous experience. And Dr. Hattie, just to go back to him, when I was deciding what to do and where to go do my postdoctoral training, I had written to about 10 different people, the top people in the country. And I got, surprisingly, positive letters. The first letter I got back was from Dr. Gaytan. In fact, Dr. Gaytan wrote me back. It was amazing. Just a few days, immediately, he called, talked to my advisor, Jim Schwinghamer, and then he talked to me on the phone, wrote me a letter right away accepting, and he said, I'd like to talk to you at experimental biology at the old Atlantic City.
The old FASB meeting.
Yeah. That year he was president of the American Physiological Society. And he, so I went to meet him in the evening, late in the evening. It was about 9 o'clock, I think he wanted to meet, and in his hotel room. And really, it was a great meeting. We talked science. That's all we talked about. We talked about all the different things he was doing, what was going on in Mississippi. I was really excited by it, and so I decided to go to Mississippi. I remember writing a National Science Research Award based on what I was doing at Michigan State. It got funded, surprisingly. Well, I wrote it by myself. It got funded. And when I came to Mississippi, Dr. Gaytan said, you know, that's great, but that microcirculation is a dead field. I think it would be great for you to work on the kidney. And at that time, the main reason I came to Mississippi was really to do mathematical modeling. I had taken a lot of engineering courses, advanced courses in math, and I got interested in systems analysis and mathematical modeling. In fact, we took Dr. Gaytan's model, using Fortran cards, recapitulated that entire model, which was about 450 equations, added the skin muscle circulation to it so that we could simulate our data. And you know, those were in the days when we used Fortran cards. So it was quite an experience, and so that's one of the reasons I came to Mississippi to do the modeling. But I remember talking to Dr. Hattie, and Dr. Hattie was not in agreement with a lot of the concepts that Dr. Gaytan proposed. And I said, what do you think about all these different possibilities? And he said, you know, I know you like mathematical modeling. If you want to do that, you need to go with Dr. Gaytan. He said, but I said, well, I do like modeling, but I also like animal research. And he, remember his words, he said, don't worry, there's a lot of blood and guts physiology down there in Mississippi, so I think you'll enjoy it.
Well, obviously you came here in '74, you had a one-year postdoc and then moved into the academic track. And you've been here for 44 years, and I suspect it was not necessarily your anticipation or your goal to stay here for 44 years. And so I'd be curious what your original thoughts were when you came here and what really contributed to your sticking around.
Well, as we were driving down I-55, which is the highway that connects Memphis and Jackson, I was driving a U-Haul truck with, my wife was driving a '67 Volkswagen. We stopped and I said, you know, I promise we'll be here 2 years. No more than 2 years, I promise. And then we'll return to the Midwest. Obviously 2 years turned into 44 years, so it's been the main reason that we stayed is just that we found this place to be a tremendous place, not only to live and raise a family, but also a tremendous place to work. Probably the most important factor that kept me here was just the steady stream of outstanding people that we had to work with. As you know, there have been 9 presidents of the American Physiological Society. I think Dr. Gaytan trained 6 of them. The others had some associations, but we have now currently 3 presidents of the American Physiological Society in our university right now. So it has been a tremendous place, mainly because of the great people in our department and the people in Mississippi. And the other thing that has really kept me every chance or every time I had an offer to leave, which there were quite a few, the first offer, as a matter of fact, was back to, I won't say the name of the place, but it was back to Ohio, which was where we thought we might end up, which was, where we were raised, both my wife and I. The second offer I had was Michigan, back to where I also loved and thought might be a place that I'd like to go to. But when we really looked at the possibilities and the opportunities there, we felt that this was the place for us. It really was the people of Mississippi and the people that we associated with, and the support that we've had from the administration. I think I've been chair during 5 vice chancellors here, and I've really had a good relationship with all 5 of them, I think. You'll have to ask them about that, but I think we had a good relationship.
Well, since they're not members of APS, I won't do it as part of the Living History program, but clearly to succeed in any organization, you have to have positive relationships with those below you as well as those above you, and obviously you've accomplished this. One of the things that I think would be very nice for you to comment upon, because I think a lot of the people who may view this Living History interview may be familiar with medical physiology, the Gaytan textbook, the Hall and Gaytan textbook, but Arthur C. Gaytan was a giant in the field of physiology. And while I know you can go on for hours talking about Arthur, why don't you share some tidbits, not a lot, but something to give our listeners a feel for who Arthur Gaytan was?
Yeah, I had the privilege of working with Dr. Gaytan, from the time I came here until he retired in '89. And so all those years, from '74 to '89, when I became the chair, but he continued to come to work as professor emeritus and work on his textbook. So we had a good association, really a good association for almost 30 years. To try to characterize Dr. Gaytan, there are a lot of legends about Dr. Gaytan, and we could go through some of the truisms and some that are not so true. But he was just a unique and special person. I've never met anyone like Dr. Gaytan. The thing that I admired so much about him was his ability to simplify complex concepts in terms of the science. I admired a lot about his personal life. He overcame tremendous obstacles in his development, but he, in terms of his science, he was not the type of person to micromanage or tell you what to do. When I first came here, he had a little room. It was a 12 by 12 room where my office and my lab. And I said I wanted to do modeling. He said, great. What I want you to do is go build a model of the kidney, because that's an area now that the model's not very strong in. And once you get that model, that'll kind of guide you into what are the unanswered questions that are important. And so that's what I did. I spent the first year really working on that model, trying to understand the kidney, which I didn't have any experience on, trying to understand where were the key issues that needed to be addressed from an experimental point of view. And he let me do that. I was concerned that I wasn't publishing.
Right.
But he said, don't worry about it. That'll all come. Just what you need to do now is address the questions. And so I think in terms of the science, Dr. Gaytan was not someone in the lab showing you how to do something. He was the person that you went to talk to understand and talk about concepts. So a lot of times we'd be sitting around the table talking about, in a group, talking about different experiments and so forth. The thing that usually came out of his mouth was, why is that important? What's the concept behind that? Not how to do the experiment, but what's the concept? So to me, that was great. Now, a lot of people didn't thrive in that type. You have to be self-motivated to succeed with Dr. Gaytan, because he was not going to go in the lab and show you how to do something. Basically, we're going to talk about the concepts. You're going to go figure out how to solve the problem and do the experiment. But on a personal level, the thing I enjoyed the most was just having a conversation with him about science, philosophy. You could talk about anything and really have a good and deep conversation with him. He was just a tremendous person.
Arthur Gaytan was president of the American Physiological Society, as you alluded to. Fran Hattie was an APS president. I'm curious how they influenced you, because you have had a long history of not only service within the American Physiological Society, but the American Heart Association, as well as other associations. So what was the importance of engaging in what I'll call extracurricular service to associations in your discipline?
Well, as you point out, it has been tremendously important. The American Physiological Society was my first scientific home. Dr. Gaytan took me to the circulation dinner immediately of the American Physiological Society, and and I won't again mention the name, but one of the people that I decided not to go to came to me and said, "Why didn't you come to my place?" Anyway, it was just the interaction with the scientists at the meeting of people. When they say meetings are important, I think they're more important to meet the people than to communicate the science. The science is important, and you can learn about that from the literature, but just meeting the people and forming those personal relationships with people at meetings, to me, is the most important part of these meetings. The service part of it, it seems natural. You're interested in meeting the people, you get engaged, you want to change things, you want to have your own imprint on the society, you want to make suggestions. And you pointed out today in your talk, it is important to go and meet people and talk to them, not to just hang back. I did that. I made suggestions. Sometimes they were followed, sometimes they weren't. But I was very active in the American Physiological Society. I was also very active in the American Heart Association. I served as editor of a journal, of the American Journal of Physiology. I served as editor of hypertension. Altogether, I think 22 years or something like that for all those journals together. But it was really a privilege. I didn't consider it something that was a duty. It was just a privilege to do that. I gained more from the service, I think, than I gave, but I gained a lot from the service. I was involved in every aspect of the American Physiological Society, going from the section chair to section advisory committee chair to president and so forth. The same was true for the American Heart. I went through a whole series of positions that I enjoyed, and again, I felt like I gained a lot. The other thing that was important to me, and this is maybe where I differed a lot from Dr. Gaytan, as I gained leadership positions in these different groups, I really made that impression on our faculty members how important it was to get engaged. And we, as you know, in Mississippi have had a long history of helping our younger faculty get into positions of leadership in the organizations. And so we worked pretty hard, and we still do, to try to get our faculty engaged in the societies and in leadership positions. And it's really to their benefit. The service is a great privilege.
Obviously, you've provided a lot of service to the society. You served as the APS president. One of the things that would be of interest is if you can comment on some of the issues that you faced as the society's president.
Yeah, I face the same issues that many presidents face, which we all want to increase the vitality of the journal and the journals that we have and the meetings and so forth. There were two issues, though, that I thought were additional issues that were really important. One was raising the visibility of physiology to the general lay public. A lot of people really don't know what physiology is, and so during that time we did embark on some attempts to raise the profile of physiology to the general public, to highlight discoveries that were made that people might not be able to interpret from the lens of a scientist, but if we could put it in language that they can understand would not only highlight physiology as a discipline, but also help people understand what we do and why it's important. Mm-hmm. So I commend you for leading a lot of that later on to really raise the profile of physiology to the community at large. And the APS, I think, is doing a pretty good job, although certainly we have a lot of room to improve there. The second issue that I thought was really important was for us to understand as physiologists that physiology is the link between the basic sciences and medicine. With the sort of the really movement toward molecular biology, and with the Human Genome Project being completed in 2000, my presidency was right after that. So, when I began to think about what should physiology be doing, one of the things that I realized really quickly was that physiology is the link between the basic sciences and medicine. We have mapped out all these genes. We don't know what most of them do. We don't know what their role is in pathophysiology. But in order to be that link, we really need to work more closely with the clinicians. And you may recall that one of the things we tried to do was to engage better the clinicians at our meetings. Mm-hmm. And I still feel that physiologists, this is an avenue that many physiologists don't recognize as really a key role for physiology. This has become especially important in recent years, where the pressures for physicians have become so great to do their clinical work that clinical research in general in many institutions has declined. Mm-hmm. Physiologists can do clinical research, but they have to partner with clinicians. And I like to use the story of how I got into obesity as an example. We had a clinician here, Dr. Herbert Langford, who was the chief of endocrinology and hypertension at the time, who I was talking to just casually, as I did a lot, and we began to talk about some of the issues he was facing, and it turned out that we recognized pretty quickly that almost all of his hypertensive subjects were overweight, obese, had characteristics which we now call the metabolic syndrome. This was back in the 80s. And I realized quickly that maybe studying how DOCA salt causes hypertension or how angiotensin causes hypertension, maybe we should shift our attention a little bit to how obesity leads to high blood pressure, how obesity occurs to begin with. So that led me into what I'm doing now, even today, which is trying to understand better how obesity not only leads to hypertension, but target organ injury. That's what led me to develop the Obesity Center here. Mm-hmm. It led me to a lot of areas. It also, I was involved in the Jackson Heart Study. Right. I was the first chair of the Scientific Directions Committee. I think our lives as physiologists are a lot richer when we understand that we are the link between the basic sciences and medicine. We can serve as clinical investigators, as population scientists, but we also have training in chemistry and molecular biology. So I think this is really an opportunity for physiologists in the future. I said that in 2001, where my president's address, I think, was something like the post-genome era, a golden age for right. physiologists. I still think it's a golden age for physiologists because we have these tools that allow us to bridge that gap between basic sciences and medicine. And I hope that physiologists will continue to be engaged with clinicians, because I think that is going to be a really, really important area, even more so in the future.
Well, you alluded to the fact that you served as editor for an APS journal, as well as for AHA, as well as other journals as well. You have worked with Dr. Gaytan on the publication of the textbook of medical physiology, which I believe is going into its 13th or 14th edition. You've published over 600 manuscripts, which is a stellar performance by any measure. And so why don't you, if you can, give some advice to those individuals who are struggling with their own publication
Yeah.
efforts, and what thoughts you might have for them.
Well, the point you make is a good one. Writing is the last step of research. If you don't write it up, it's really not completed. Now, there's another aspect of that has to be emphasized as well. Just because you did something doesn't mean it should be published. Okay. So I really emphasize to the people that work with me, first of all, learn how to write well. I give them all a book on writing and publishing scientific papers. Everybody that works with me gets that book. They also get a lot of red ink. Now it's tracking on Word, but we learn how to write together, and I emphasize to them how important writing is and effective communication is. So that's first. The second thing is you have to be accurate and careful when you write. My former mentor, a little bit different, I think I mentioned this to you previously, had a blank sheet of paper above his desk that said there's nothing scarier than a blank sheet of paper. His point was it's an awesome responsibility. It's there for a long, long time. So make sure that what you write is accurate, make sure that it's understandable, and make sure that the work that went behind that is careful and reproducible. So that's why I say you shouldn't necessarily publish everything that you do. You should publish what you think is, is going to be useful, that's careful, reproducible, good science. The textbook is another, it's a different type of writing. And I learned this from Dr. Gaytan, that when you're writing a textbook, particularly a textbook like medical physiology, you're not writing for your colleagues. You're not writing for professional physiologists. You're writing for students or healthcare professionals. So you have to put it into verbiage that is easily understandable, that's clear. You should do that with your scientific writing, but it's a different style of writing. So those two things, the textbook and the scientific writing, are a little bit different. The common thing is clarity. That's the common theme, and it is important to write. I've learned a lot. You know, every time you write a paper, you learn a lot because you review the literature more. It's really, you know, I enjoy writing.
One of the things that brings to mind the fact that I personally think you are an outstanding scientist researcher. But one thing that has characterized your career is your commitment to education, and you've gotten numerous teaching awards. Many people come to an academic position and they're either teachers or they're researchers, not both. Tell us why it is so important for you to be able to straddle both worlds to become a successful academic.
Well, the main reason it's important is I like to do both. That's the main reason. If you don't like to do something, then probably you're not going to be good at it. So I'm not saying I'm good at either one, but I like to do both.
But you've been successful at both.
Hopefully. I think education is really, really the most important thing you do as a scientist. You know, I always think about my wife as a third grade teacher. I tell her what she does is prepare people for the future generations. She teaches third graders, if they're well educated, they can go out and be successful. I think the same thing is true in science, that the people that we teach are really our offspring, the future generations of scientists. And so that is an enduring sort of thing, and when you think about it. If they're good teachers also, the next generation will be good. If they learn well and they learn good habits, they can become good educators. I don't think you're born to be a good educator or not. I think if you have a passion for it, you enjoy it, you'll work hard to try to become a good educator. So now a lot of what I do is, in recent years, been more in postdoctoral training and young faculty. I review the grants from many of the young faculty members in our department. You know, I review their papers, many of them. So I think it's, you know, helping people become good scientists is probably as important, if not more important, than actually performing the science. I think those two are not mutually exclusive. They go hand in hand if you enjoy both things,
Right.
and which I do.
You brought Becky up, and it's a good time to ask what role Becky and your family has played in your career and your career advancement.
Well, I wouldn't be anything without Becky.
Okay.
So I have to give her a lot of credit. I've told this story before when I received an award one time for some research that I did that was really arduous. It required me to get up every night. It was an experiment that we were doing to try to understand the concept of pressure natriuresis and its role in blood pressure regulation. And we had built a servo control system, which I'd worked with Robert Hester to develop. And Joey Granger was, I think, a student at the time, a graduate student with me. And we'd worked on that, but we hadn't perfected it. What we had to do was to servo control renal artery pressure.
Mm-hmm.
And it turned out, of course, if the thing failed in the middle of the experiment, we'd have to start all over again, and this was something that lasted maybe 2 weeks. So if you failed on day 5 or day 6, you have to start, get
All
control
over again.
measurements, and it was really a mess. So the first few nights, I came up here and stayed all night, watching things, checking every hour. And then we worked out a system where we could check it by the computer using the old modem, where you call the number up and check your blood pressures and so forth. And I was doing it every hour at night. I was getting pretty tired. But Becky then volunteered. I didn't ask her to. She said, maybe I could help you a little bit if I could check for you, and if things are not working right, I can wake you up. So I can tell a lot of stories like that, but Becky has been a real rock for me in terms of not just raising our family, which she did a lot of times when I had to go to meetings, which I did, and leadership opportunities that I had. She would take care of things. I did coach the kids when they were little on their sports. I coached them in soccer and basketball and baseball. But she was there when the kids, when I was out of town taking care of them. Becky has been tremendous in supporting me in what I've done. When we came to Mississippi, I said, I'm sorry, but we're going to come for 2 years. Is it okay? And she said, I go where you go. And so that's been a tremendous. The kids are the fun part.
Mm-hmm.
The kids have all been great. They're fun. But as you know, the grandkids are even more fun. So the great thing about the grandkids is that we can send them home when the day's done.
When you're done with them.
But yeah, my family has been really important to me, and Becky has been, I can't emphasize enough how important she's been to any success that I've had. She's been tremendous.
Great. Let me ask you one last question, and that's really your advice for young people starting out in their careers today. What advice would you give them? Obviously, it is much different today than when you and I started in terms of resources for research. And there are a lot of people seeing their mentors struggling to get funded, and people questioning. So what advice would you give to them?
Well, I'm always reluctant to give advice on how to achieve or be successful, because I don't think there's one path to success. You look at different people, they have different paths. But there's some common things that I think are essential. They play a permissive role in being successful. The first is you really have to love what you do. In this field, it's a tough field. Writing grants, competing for grants, writing papers, getting rejected. You really have to love what you do. And if you do that, if you really love what you're doing, it's really not work. So, I do spend a lot of time at work. Becky has to call me and say it's time to come home for dinner. The point is that it's really not work for me. So that's the first and most important thing, to really find a passion. And that goes throughout education, through research. Even when you're doing experiments, you're never as interested in the experiments that someone else has suggested to you as the experiments that you think of yourself. That's a rule, I think, that's true for anybody. So, find your passion. You'll be successful, I think, if you really find something you really enjoy doing. The second thing, which is common, I think, is that you have to find really a good mentor or mentors. You should have multiple mentors throughout your career. I even have mentors today. You know, I think you should have mentors for different aspects of your career. People that you can go to for advice, that you can trust their advice, and you can trust that they want to help you be successful.
Right.
So having good mentors, I mentioned high school mentor, the college mentor, the graduate school mentor, postdoctoral mentor. They all had a tremendous role in whatever success I've had. The third thing is surround yourself with people you like to work with. I've had a tremendous group here, as I mentioned, in Mississippi. I can name a few of them. I hate to name a few of them, but
Because you'll leave somebody out.
I'll leave somebody out. But I've had, you know, my first graduate student, Joey Granger. He's very, very outstanding, successful scientist. First postdoctoral fellow, Elio Salgado from Brazil. He ultimately became chair of the department there. He also is still sending us students. You met one of them today. So I've had tremendous people to work with here in Mississippi. That makes it fun. It makes it nice if you like these people, which I have made sure that I like the people I work with. So those three things are very important. There are other things that are important. I think I always tell people, take your briefcase home every night. They ask me, well, why do I take my briefcase? And I tell you, you have to read. You have to read about science. You have to, and that's where you get ideas for new projects. If you're not reading and studying, it's a lifelong thing. You probably are not going to be successful. So when I say take your briefcase home every night, I make it a habit. Even when I know I'm going to have a booked up evening, I take my briefcase home. Hopefully I'll have a chance to read something. The other thing that I learned from Dr. Gaytan is, and this was especially from Dr. Gaytan, is you know, the question is the most important aspect of the research. A lot of people, they have a hammer and look for a nail. You know, they have a tool, looking for some way to use that tool to do the research. I think you flip it. You say, I have a question, then you look for a tool to answer that question. And Dr. Gaytan was really, really big on that. He asked us all the time, you know, why is that important? You know, what's the concept here that you're getting at? Why is that new? To me, that's the critical part of the research. And that ties in well with taking your briefcase home every night. Persistence, all those other things that people say are important. You have to work hard. We know that you have to work hard. As I said, I don't think it's work when you're really enjoying it. But people that achieve success usually have to really work hard at what they're doing to achieve really high level of success. The last thing I want to mention, I could mention more, but the last thing I tell people in our lab is you have to feel lucky. You have to feel lucky. And by that I mean, you know, I feel like I've been lucky all my life. I mentioned a few cases where I thought it was really lucky. But feeling lucky means that, you know, when something doesn't go your way, you can look at the bright side. You can say, oh, that didn't turn out the way I wanted, but, you know, that takes you to a new avenue that you weren't thinking about. And a lot of the experiments I've done, really, that were really great experiments, were going in new directions that I hadn't even thought about. So I think having that that attitude of, you know, feeling lucky, looking for opportunities is really important. And then one last thing is that take care of your health. I always advise people to take care of their health because in order to work hard, you have to be healthy. If you don't feel well, usually it's difficult to be successful and work hard. So take care of your health is a really important thing.
John, let me finish by thanking you for your willingness to sit for the Society's Living History program. I've learned a lot about you. I've gotten to know you over my 33 years at APS, and I hope our listeners will learn a little bit about you as well. And so on behalf of the Society, thank you very much.
Thank you, Marty. It's been a real pleasure and an honor. Thank you.